So without any further ado, I want to invite Dick Slansky, our ARC's senior analyst specializing in the PLM space, to present on his view of the virtual simulation market.
Also, just a quick note too on the questions. We also have a microphone, so if you just want to just take a microphone and ask a question, when we get to that point, you can do that too. So, okay. It's interesting, the title I have here, I say design, build, operate. I think the key word here is kind of operate, because this kind of simulation and the things that we're going to be talking about in this virtual, here we go, is that better? Thank you. And in this virtual world that we can create now for our production systems is really, is taking it down into the operations of whatever the industry is, whether it's machine tools, whether it's mining equipment, but whether it's a plant or a production line. You know, this is really where this is becoming a very beneficial technology. So let me just kind of quickly jump into this. I'll try to make this as brief as I can so I can give our main presenters plenty of time. Oops, are we working here? There we go. Good grief. All right. So the virtual simulation basically validates one of the messages I want to get across is it validates across all the domains of the product lifecycle. I mean, we've been essentially designed the product as virtual because CAD systems, that's what it really represents, but we're really taking this down, this virtualization is driving it across all of the domains of the lifecycle, through manufacturing and down into the shop floor, into the operations, out into the field, whatever the case may be. And so basically what we're saying is that the manufacturing processes, automation, maintenance, have become virtualized across the entire product lifecycle. The PLM scope has really expanded from just design build to design, simulate, validate, build, support, maintain. So we're really expanding the overall scope of the lifecycle itself. These types of simulation tools, and they're coming in all types and flavors, if you will, from the PLM side, the suppliers, but we're seeing it emerge from all different areas, as you'll see today, from one of the sponsors that brought their customer. So it enables, what it's enabling the user to do in any, actually I might emphasize, any industry, is to create this virtual environment across all of their operations. So basically what we're doing is the basic idea is we want to validate the physical world through the simulation of the virtual world. So you can kind of look at this as a virtual life cycle. Now these are just, this just represents in a continuum, just the product life cycle as we kind of know it today. But what we're really looking at now is kind of a concept of create, simulate, and validate across that life cycle. And so we're looking at virtual design, virtual test, virtual build, virtual production, and virtual support. So, you know, these two areas over here, virtual design and virtual testing, have been around a long time. That's CAD, CA, and all that. But we're moving it across the entire life cycle. So we're covering product, process, and production, and all of this runs nicely on today's collaborative PLM hubs too, which is something that ties all this together. So really, what we really want to talk about today, and I think this will kind of come across as our main presenters tell their story, is the value proposition for this, for virtual simulation. These virtual environments can be, as I said, created to simulate entire production systems, machine tools, field operations, and maintenance. You're replacing expensive physical prototyping that had to be built to test out systems. We're replacing that with virtual testing. As I said, you know, this is already the accepted standard for realistic product testing. This has been around for decades, but now we're just moving the scope of this down across the entire life cycle. And this is significant too. We can really shorten the production ramp-up time leading to faster production launches. And this is the real value proposition here for the companies and their products, and getting their products out to market. And then, of course, virtual commissioning for production systems, it reduces the time to launch and physical commissioning costs. That's a completely different aspect. We're not really dealing too much with virtual commissioning in this particular session today, but it's so as I said, we've been in the virtual 3D design world for a long time. So we're moving through that section of the life cycle through this innovate and concept and the actual design aspect of it, the product design and the product test. Okay, so and where we've been moving to for some time now is into the virtual build or the digital manufacturing space, where we have tools that begin to, well, not begin to, they have been there for some time, where we actually have the manufacturing process design, and we use we integrate the product design with the manufacturing process and manufacturing planning and manufacturing the design of the manufacturing processes itself, and then production process simulation, and then that then translates out to the physical implementation, which is the automation itself, the physical world of the automation itself, like a robotic welding line in let's say a body in white line in an automotive plant, for example. And I think the final step in this is the virtual production, where we're validating the build, and this is the notion of we've got production process and work instructions. This is where we're getting down into the shop floor operations, the execution area, and we can simulate the production system itself, and then we get down to the actual shop floor and execution, and we're dealing with taking all of these shop floor completed records, quality assurance records, and all these as-built in reality that's being kind of stuffed away in some repository, and really start to use analytics and start to look at this stuff and really start to go back and to really realize the benefit of continuous process improvement, and really, so we're seeing some tools really emerge in that area. So it's really validating the as-built to the as-designed. And what this represents here is that this type of simulation on the production level, we have the product life cycle above, we have the physical production system kind of design, build, operate that I've been talking about, and then we want to create a virtualization of that in a very realistic way and in a dynamic way to test it and to validate it and so on with the tools that we have today, and with the end result being reducing the time and costs of the production launch. And it still remains one of the biggest challenges for manufacturers today. So we're seeing that PLM technology really offers this next generation 3D simulation tools. They're out there to create a fully immersive, this is really interesting and important point, a fully immersive virtual reality simulation. So we have tools out there that would enable simulation of an entire offshore drilling platform or a process plant, or in the case of our mining equipment company here, it's going to be very interesting. You'll see what they have and how they're using it. Engineers can now virtually and accurately simulate not just a machine tool or a robot or a work cell, but the entire factory and the entire production systems within it. You know, the concept is this virtual factory involves, it's an integration, it's a holistic process, it's an integration of the entire process from product design through the manufacturing processes, all the mechanical and electrical systems, the systems engineering. We can simulate all of that today, which is basically what I just said. We're using virtual commission. So where this is going from the discrete world, now PLM is, and this kind of simulation stuff, and what we're seeing today is going to be pretty much examples of discrete manufacturing, discrete types of products. where we're seeing this going is into the power, process, energy, and AEC world, where these virtual simulation models here are not only just realistic and rendered realistically, but offer actual embedded information and enable companies in the process industries to create this fully immersive environment. They can look at they can use it for training, they can use it for safety and risk mitigation, all kinds of different things. So we're seeing a move towards that area today. The engineering disciplines for this automation design within the virtual within this virtual production environment really involves a lot of the typical engineering disciplines that we know and that we've been using: mechanical design, electrical design. You get your controls design, tool and fixtures, all of this kind of stuff, and of course the virtual simulation. But the simulation engineer or the simulation engineering touches all of these disciplines across the production engineering environment. And if you look at it from a systems engineering perspective, and this is a little bit a fairly complicated graphic here, but basically the idea is taking this systems engineering approach of integrating multiple engineering disciplines and applying it to production systems and then validating it virtually. So you have the as designed, the as simulated, and the as built as kind of the final output. So some of the future trends I see in this area is that we'll see a continued 3D virtualization of all domains, as I've been talking about. We're going to see digital manufacturing and virtual production simulation adoption by those industries, power process, AEC, as I mentioned. We're going to see the virtualization of the production processes will enable the implementation of smart assembly and ergonomic improvement within the production processes. We're seeing a lot of work being done in that space now. We'll actually see that these virtual environments will allow companies to actually drive the optimization of their shop floor and factory floor operations back up into their not only their manufacturing processes for improvement and optimization, but possibly all the way back up into the product development. Basically what I'm saying is the physical world will be validated by the virtual world. Okay? And with that, I want to bring on our first speaker.